Hey beautiful minds, welcome to Genzlearning. In this video, we will be learning the topic projectile motion under the chapter motion in a plane. In the previous video, I have already uploaded the part 1 on the topic vectors. Do check it out if you haven't. And now we will be doing the part 2 on the topic projectile motion. So let's begin. Projectile motion. It is a form of motion in which an object or a particle is thrown near Earth's surface and it moves along a curved path under the gravity only. It is parabolic in nature, for example, javelin throw and throw ball. A ball is thrown along a curved path. This motion is called projectile motion and this shape is called parabola, and that is why it is parabolic in nature. Next topic is time of flight. Here I have a parabola whose angle is theta with initial velocity u. We know that theta on x-axis is cos theta, so we get u cos theta. And theta on y-axis sin theta, so we get u sin theta. In time of flight, we will be considering the vertical axis, that is the y-axis, so the initial velocity will be u sin theta. When a particle is moving upwards until a certain time, when the height is maximum, then here our final velocity will be equal to 0. So using the first equation of motion, v is equal to u plus at, where final velocity is 0, initial velocity is u sin theta, and since acceleration is moving upwards against gravity, we get minus g. And t here is time. Putting all these values, we get 0 is equal to u sin theta minus gt. Placing minus gt on left hand side, we get gt is equal to u sin theta. Keeping t alone on left hand side, we get t is equal to u sin theta by g. Since the total time is 2t, that is this whole thing, we get t is equal to 2u sin theta by g. And this is how we derive the formula for time of flight. Next topic is height of a projectile. There is a parabola drawn whose angle is theta with initial velocity u. In height of a projectile, we will be considering the vertical axis, that is the y-axis. So the final velocity will be 0. And initial velocity will be u sin theta. Making use of the third equation of motion, v square is equal to u square plus 2as, we get 0 is equal to u sin theta whole square plus 2 minus gh. Next we get 0 is equal to u square sin theta square minus 2gh. Placing minus 2gh on left hand side, we get 2gh is equal to u square sin theta square or sin square theta. Keeping h alone on the left hand side, we get h is equal to u square sin square theta by 2g. This is how we derive the formula for height of a projectile. This is the height of the formula we just derived. Next topic is range of projectile. There is a parabola whose angle is theta with an initial velocity u. We will be considering horizontal axis because this is range and we need to derive the formula for range. So range is equal to horizontal velocity into total time. We get horizontal velocity u cos theta into total time, that is 2u sin theta by g. Multiplying, we get 2u square cos theta sin theta by g. From trigonometry, we know that sin a plus b is equal to sin a cos b plus cos a sin b. We get sin theta plus theta is equal to sin theta cos theta plus cos theta sin theta. Then sin 2 theta is equal to 2 sin theta cos theta. Applying this here, we get r is equal to u square sin 2 theta by g. This is how we derive the formula for range of projectile. Next we have maximum range under range of projectile. R is equal to r max. Then r max is equal to u square by g, where sin 2 theta is cancelled out because theta is 45. Next topic is equation for trajectory. In the first part, we will be considering horizontal motion. Making use of the second equation of motion, s is equal to ut plus half at square, where s is displacement, u is initial velocity, t is time, and a is acceleration. Now only focus on horizontal stuff, not the vertical stuff. S is equal to x-axis, u is u cos theta into time plus half. Remember this, horizontally acceleration is always 0. Then we get x is equal to u cos theta into time. Isolating t we get t is equal to x by u cos theta. We will be considering this as our equation 1. For the second part, we will be considering vertical motion with the same equation of motion. Now only focus on vertical stuff and forget about the horizontal stuff. S is equal to y because y-axis, u is u sin theta into t plus half. Acceleration here will be minus g because acceleration is going upwards, whereas gravity is downwards, into t square. Now in place of t's, use equation 1. We get y is equal to u sin theta into x by u cos theta minus half g into x square by u square cos square theta. We get y is equal to tan theta. How? Because sin by cos into minus gx square by 2u square cos square theta. This is how we derive equation of trajectory. The equation is in the format y is equal to ax minus bx square, where a is tan theta and b is g by 2u square cos square theta and b is constant. Also remember that trajectory is parabolic in nature. Next topic is instantaneous velocity v. In this diagram, we have to derive the formula of v, instantaneous velocity. So let's derive. In horizontal motion, using the first equation of motion, v is equal to u plus at, where v is final velocity, u is initial velocity, a is acceleration and t is time. V is equal to vx because x-axis, initial velocity is u cos theta, and in horizontal motion acceleration is always 0, so plus 0. We get vx is equal to u cos theta. Next, in vertical motion, with the same first equation of motion, we get vy because in y-axis equal to u sin theta, and acceleration in vertical motion will be minus g, so minus gt. Now instantaneous velocity is given by v is equal to root of vx square plus vy square. We get v is equal to root of u cos theta whole square plus u sin theta minus gt whole square by putting the values we derived for vx and vy. And this is how we derive instantaneous velocity. The next topic is time of fall. In the given diagram, h is height, r is range, u is initial velocity and v is final velocity. We will be considering vertical motion. Making use of the second equation of motion, s is equal to ut plus half at square, where s is displacement, u is initial velocity, t is time and a is acceleration. S is h equal to initial velocity is 0 because the particle is falling downwards. If the particle was moving horizontally, we would consider initial velocity to have some value. Plus half, acceleration is positive g because it is accelerating downwards. T square. Isolating t square, we get t square is equal to 2h by g. By removing the square of LHS and rooting RHS, we get t is equal to root of 2h by g. This is how we derive time of fall. Let's move on to the last topic of the chapter, the questions. First question. A body is thrown with a velocity of 30 ms minus 1 at an angle 30 degrees horizontally. Calculate the time of flight of the body and maximum height attained by the body, where gravity is 10 ms minus 2. Initial velocity is 30 ms minus 1. Angle is 30 degrees. Gravity is 10 ms minus 2. The formula for time of flight is t is equal to 2u sin theta by g. Putting the values in, we get value of sin 30 is 1 by 2, so we get 60 by 20, which is 3 seconds. The formula for maximum height is h is equal to u square sine square theta by 2g. Putting in the values solving this we get 11.25 meters. Second question. A stone is thrown from the horizontal ground at an angle of projection of 30 degrees with a speed of 49 ms minus 1. Calculate time of flight and horizontal range. We know that theta is 30 degrees, speed that is u is 49 ms minus 1 and gravity is 9.8 ms minus 2. The formula for time of flight is t is equal to 2u sine theta by g. Putting in all the values further solving this we get t is equal to 5s. R is equal to u square sine 2 theta by g. Putting in the values we will be multiplying 2 inside and get R is equal to 212.2 meter, which is 212.2 meters. This is the range. Third question. An arrow is thrown in the air. Its time of flight is 5 seconds and range is 200 meters. Determine vertical component of the velocity of projection, the horizontal component and maximum height where gravity is 9.8 ms minus 2. T is 5 seconds and R is 200 meters. With the help of time of flight's formula, we can determine the vertical component of the velocity, which is u sine theta. Now we isolate u sine theta and get u sine theta is equal to gt by 2. Now we put in the values and get u sine theta is equal to 9.8 into 5 by 2. Further solving this we get u sine theta is equal to 24.5 ms minus 1. To find out the horizontal component, we make use of range formula. We know that sine 2 theta is 2 sine theta cos theta. Using this we get R is equal to u square by g into 2 sine theta dot cos theta. Then we expand u square and get R is equal to u into u by g into 2 sine theta cos theta. We multiply each u with sine and cos and get, now we isolate u cos theta and get u cos theta is equal to gr by 2 into u sin theta. Putting in the value of r and u sin theta we get, also do not forget the value of g is also given. U cos theta is equal to 9.8 into 200 by 2 into 24.5. Further solving this we get u cos theta is equal to 40 ms minus 1. The formula for maximum height is h is equal to u square sine square theta by 2g. Putting in the values we get 24.5 whole square by 2 into 9.8. Further solving this we get h is equal to 30.6 meters. Final answer. Fourth question. A cannon is to fire up to 500 meters horizontally. What should be the angle of projection if the shells are fired with a velocity of 100 ms minus 1? From the question we know that range is 500 meters and velocity is 100 ms minus 1. Through formula of the range we will be able to find the angle. Next we put in the values and get, one more thing, I forgot to add the value of gravity. It is 10 ms minus 1. 500 is equal to 100 square into sine 2 theta by 10. Isolating sine 2 theta we get sine 2 theta is equal to 5000 by 100 into 100. Solving further we get sine 2 theta is equal to 0.5. 2 theta is equal to sine minus 1 0.5. We get 2 theta is equal to 30 degrees. Dividing 30 by 2 we get theta is equal to 15 degrees. This is the answer. Congrats guys, we made it till the end of the chapter. Thank you for watching. Hope you liked the video and hit that subscribe button for more such videos.